Alrighty, section 1.4 paths. Okay, so a path in the complex numbers is a continuous function gamma that takes some interval AB of real numbers to the complex plane. And they're pointing out that AB is a closed interval. And the real numbers are. Okay, so typically they'll use a T as the parameterization. So, for A less than or equal to T less than or equal to B, we'll use gamma of T. And so this probably one of the simpler ones that you might come up with is, for instance, you could define gamma of T as e to the IT for 0 less than or equal to T less than or equal to 2 pi. And, so what's happening here is, if we talk about this e to the IT, remember that's cosine t plus I sine t, and e to the IT is the unit circle. And, so what this makes is we start here at 1, and by the time we get to pi over 2, we've gotten to here at I. And then when we get down here to minus 1, that's for t equal pi. We get here to minus I at 3 pi over 2. Then we'll get back to 1 at 2 pi. Okay, so that's a path. And that's the idea. So, now, so we could have done the same path as cosine of t plus I sine of t. And we could have thought of it as the x part, right? Z equals x plus IY, or we would have said x equals cosine of t and y equals sine of t. Okay, so we have that. Now we could have even gone a bit further, I guess. Let's see. No, I guess we'll have to come back to it. We'll come back to this example here in a moment. Now we hopefully we all remember what continuous means. So they point out in the book that gamma is continuous if for all a less than or equal to t less than or equal to b, we have that the limit as t as they use a t0. T goes to t0. of gamma of t is equal to gamma of t0. Okay. All right, so we have that. We can take derivatives. Now, so the derivative of gamma at t0 is denoted gamma prime at t0 and is equal to the limit as t goes to t0, and they use this particular definition, gamma of t, gamma of t0 over t minus t0. But we could also just say the limit as delta t goes to 0 of gamma of t0 plus delta t minus gamma of t0 over delta t. So we could use that, or my personal favorite is I tend to just use an h, and so gamma of t0 plus h minus gamma of t0 over h. Okay, so for our example, we had gamma of t equal e to the it. So gamma prime of t. We would do all that limit stuff, but we know how to do this with a chain rule. We would get I e to the it. Now, what if we check that out with, if we write this as gamma of t equals cosine t plus I sine t. Okay, so now gamma prime. Again, we know these derivatives, so we would have minus sine of t plus I cosine of t. And we've actually already seen this where I think they took the derivative earlier in the text. Now, if we multiply through by I, we get e to the, let's see, am I doing e to the I theta or e to the, I just lost what, oh, I got to come back here. I did it, yeah, e to the I theta. Okay. Now, so again, if we factor out the I, I just all of a sudden was thinking negative I for some reason. I don't know why. But if we factor out the I, this is I times cosine of t. And then again, plus I sine of t, because I times I is -1. And so you see, we get the same idea, is that, back here, we said gamma prime was I e to the it, or in other words, I times gamma of t. And here we again see that it's I times gamma of t. Okay, and for that matter, if we had just set this up as the real part and the imaginary part, and we said, oh, well, x is cosine t and y is sine t, then, we would see that x prime is minus sine t, and y prime is cosine t. So, we can do it separately this way as just x and y, in which case, what we would do is just call that a parameterized curve in real numbers in the Cartesian plane. But because they're x's and y's, and we can think of complex numbers that way, it's in the complex plane. So we can pretty much take these derivatives just as we have done in the past, as long as we know what this gamma function is in terms of x's and y's. Okay, let's see. Okay, so let's look at, a couple more paths. I guess I'll do this slightly out of order at this point. And I guess given I'm doing it out of order, I could have done it a little earlier. And so we can talk about a segment. Let's see, I'm trying to look to see if they, I think they define, so, I don't want to go quite that way, I guess. I was just looking at their definitions. But, a path can be defined piecewise. Having a little trouble there writing, but okay. So remember, it's supposed to be from A to B, this nice segment. But, going back to our path of e to the it, I showed that we could do that with cosines and sines, but also remembering we're making a circle here, right? Okay, the top half of the circle I could think of as y equal the square root of 1 minus x squared. And the bottom half I can think of as y equals minus 1 minus square root of 1 minus x squared. So you see, what I could do is, so x, to get the top half, I could define this in terms of x could just be t, and y could be the 1 minus t squared. So you see, it's just this function of t. Now, so that's the top half, and in this case, -1 is less than or equal to t is less than or equal to 1, right? And that gets us all of that. Okay, now though, and I'm starting here, and I'm going around like that. Okay, so there's a path. Now, what if I wanted to start here and go around this way? Okay, well, so I sort of need to change the -1 into a 1 and so forth. Well, I can do that simply by messing with the t's here. Is that, okay, I need t to start at, I'm really worried about this t here, and whatever I do to it, I'll fix that one. So I really want t to start at 1 and end at -1 somehow. So though, if I take if I but I want, so suppose I want to call this like 0 to 2, right? So suppose I wanted to say 0 is less than t is less than or equal to 2 instead of this up here. Well, can you find a function that would take t equals 0 to 2 and turn it into -1 to 1? Okay. Oh, sorry. And actually, I want it to go from 1 down to -1. So can I do this? Well, certainly I can, right? So here's a subproblem. There's 0 to 2, but I want to start at 1. So there's 1. There, oops, there's -1. Okay, so I could just use that line. Well, what's the slope of that line? I can go through point slope form and all that kind of stuff. Slope of that line though is -2. -2, +2, and the intercept is -1. So what would that do? If I start at 0, I get a -1. Really? T equals 0. 0. Oh, yeah. I knew I wanted a slope of -2. Sorry about that. Try that again. I didn't plot my points right. There's the 0. So I want to be up here at 1. And then when I get out here to 2, I want to be down here at -1. You're supposed to yell at me through the video when I do that kind of stuff. Okay, so the slope is -2, t, and then an intercept of 1. And so if instead I said x equals negative t plus 1, negative 2t plus 1, and y is equal to square root of 1 minus negative 2t plus 1 squared, like that, then I have at this point 0 less than t less than or equal to 2. And I have just made the top half of the circle going around like that. Okay, well, the bottom half of the circle, I need to start at a -1 for the t and end at 1. Okay. And I need to use y equal the negative of the square root. Okay. Well, so the big thing is now, though, I finished at 2, so I need to start at 2. So I want 2 and probably to get all the way to 1 to make my life easiest. Maybe I want to go to 4. Excuse me. And again, though, at 2, I need it to be -1, and at 4, I need it to be 1. And so it looks to me this is just t minus 3. And so if I use, in this case, x equals t minus 3, and y equals negative the square root of 1 minus t minus 3 squared, that will give me this bottom part. And so now on my interval for 0 less than or equal to t less than or equal to 4. Okay, so it takes some work to make this piecewise function, but I did it. What I have then is that my x will just equal t. Okay, but my y is, in this case, a piecewise function, and it is the square root of 1 minus, what was that again? negative 2t plus 1, negative 2t plus 1 squared. And that is for 0 less than or equal to t less than 2 or less than or equal to 2. And then minus 1 minus t minus 1 minus 3 squared when 2 is less than or equal to t less than or equal to 4. Okay, and so there I have my gamma. Well, I wouldn't call it gamma of t like that, I guess. I would just have it as my separate x and y. But that's how I would determine my gamma of t. And so I can do this in pieces, okay? So way back, so a path can be piecewise, because for any given parameterization for each piece, I could fix it up to make it work. Okay, so a path can be piecewise. So, you know, this whole thing, very complicated. I like the cosine t, I sine t thing much better, you know, or x equals cosine t, y equals sine t. Much better than these rectangular coordinate stuff. Okay, but it can be done, and we can make our, you know, we can end up making a path that fits the definition of a path, being that closed interval for t. You know, so our closed interval was from 0 to 4. We can do that and make this thing work. Okay, so there we got a path. All right, so that was the piecewise part. I've gone quite a while on this, so we'll continue with paths on some more videos. So we'll stop here.